computer
I
and I'll
don't
send
know
it to you.
what the fuck that means.
Yeah, I'm gonna record it on my computer and send it to you afterwards. Okay. So we were talking about
Thank
radians.
you.
Let me just quickly, say what I've said so far. 1 pi radians is 180 degrees. That's like the main idea. Everything beyond this is just you can build
Okay.
on from this. So you can use the ratio method to convert things between radians and degrees. So for example, you know that pi radians is 180 degrees. So if you want to find out how many radians is 270 degrees, write it down like this. Cross multiply, you get an equation because 270 times pi and 180 times x, and then solve for x. You'll get this. If you don't want to do that, use these
Yeah.
formulas, which I used to not like, but you gotta do what you gotta do. So radians times 180 over pi will always give you degrees, and degrees times pi over 180 will give you radians. So they're just opposite of each
Would I
other.
lose marks if I just went for the method on the left? Because I know sometimes in the mark scheme it's like
No, no, no.
they
You
want
would
you
never.
to go for a certain method.
So no,
Okay,
you would
nice.
never lose points for this because if you think about it, look at what you've done. Essentially, you're multiplying by pi over 180, aren't you? So
Mm.
you derived the
Oh
formula.
yeah,
So it doesn't really change anything. It's the same thing.
yeah,
So you'll
valid.
end up, yeah, because math is very consistent. Um, 1 second. Okay. So that is everything about radians. That's essentially everything you need to know about radians. Now, to have a more formal like definition of a radian, definition of a radian. So definition of a degree, by the way, very few people know this, but a definition of a degree is you break a circle down into 360 bits, equal bits, and each one of those bits will be 1 degree, which is a very not, you know, fun definition. For a radian, the definition is a bit more interesting. It says that if you draw a circle, a unit circle specifically, meaning a circle with a radius of 1, and you make an arc that somehow has an arc length that is exactly equal to the radius of the circle. Okay. So if you make a circle where the arc length is exactly this length of the radius of the circle, the angle you would need to make that arc would be 1 radian. That's the definition of a radian. Okay. Pretty weird, honestly. I don't think I've
Okay.
ever used this in the real world, like this idea in the real world. But you should know that this is, just in the back of your head, you should know that this is a thing. Now, let's talk about some,
Okay.
ways to think about how thinking in radians changes everything we know so far. Let's talk about the graph, for example, of y equals sine x. 1 second. So y equals sine x. So I don't know if you know this, but the sine graph looks like this. So this is one period of it, right? So if you
Yeah.
know, so do you know what one full period of a sine graph is? Like what's the
Um.
full length of it?
No, honestly, the periods confuse me a lot.
They're always 360. So there you go. No more confusions. The one full period of sine and cosine is always 360
Okay.
degrees. It's basically one full rotation of a circle. Think about it like that. Okay. So kind of odd, isn't
Yeah.
it? It's a bit stretched out. That's better. Okay. Um, that's one full period of a of a sine graph is 360 degrees. Now, which means that since it's symmetric, I tell this to all my students, it's so cool. Since it's symmetric, this is 180. And since again it's symmetric, this must be 90 because half and half and half, right? So this makes
Yeah.
life easier. If you just know that one full period is 360, you can draw the whole thing. You know every single point on it. So this is 1, remember, and the bottom is always -1. They don't go beyond that. And what else? What else? That's pretty much it. So if you want to be fancy, you can say that this is 270 because 180 plus 90 is 270. But that's essentially all you need to
Yeah.
know about a sine graph. However, since we're talking about radians, right? Degrees are old news. We should be talking about this whole graph in radian terms. So maybe I should just copy the previous one, show you the alignments. So here, let's talk about how these numbers change because of radians. So let's start with 180, since we know that 180 is just pi, right? Since 180 is simply
Yeah.
pi, that means that 360, what do you think 360 is in terms of pi?
2 pi.
There you go, 2 pi. So obviously 2 pi. So what do you think 90 is?
Um, 1/2 pi.
pi over 2, exactly. And this would therefore be 3 over 2
All
pi.
right.
Might not be as obvious, but oops. Sorry, give me one moment.
Take your time.
All right, so that is basically your sine graph in radians. As you can see, 360 is 2 pi, 270 is 3 over 2, 180 is. But honestly, like this is not something you should even try to memorize, right? Because like to
Yeah.
me, honestly, memory in math is the least useful thing. Muscle memory, on the other hand, is super useful. Everything I just did here was muscle memory. Because you see, I was building the graph real time. I didn't remember all of these things. All I remembered was that the total period
Yeah.
is 360, and I kind of built from there. So if memory is not your, actually, memory is your strong suit, isn't it? I just remembered.
Yeah.
Yeah, for me it isn't. So, um, anyway, so that's basically all you need about radians, the basics of radians essentially. Let's talk about some uses of them now. Now, so when you draw a circle, right? Uh, this is called what is called? Do you know what it's called? This thing,
Which part?
this little pizza slice I just made.
Um,
It's called a
forgot.
sector. It's a sector of the circle, basically. Okay, and we call this length.
Yeah.
Oops. What do you think we call this length? Any idea? The arc length.
Nope. Thor.
So arc length.
Okay.
So it's an arc, so arc length. And these are of course the radii. Now, the thing is, if you wanted to find for example, the arc length, so we call it L, by the way, just small l. So if you wanted to find L, if the angle is in degrees, we do something very interesting. The formula is simple. What's the total circumference of a circle? Formula for the circumference of a circle?
Forgot it. Again, like I haven't went
It's like
over this in a while.
2 pi r, right? Remember this?
Yeah.
This guy gives you the total length of the
Yes.
circle's outline, basically. But since we don't want the whole outline, we only want a part of it. How do I define that part? I say, out of 360 degrees, I only want theta degrees. See? So this formula kind of makes sense, doesn't it? I want this fraction of 2 pi r. And that tells me the arc length. Make sense?
Okay. Yeah.
Right? Okay, and similarly, if I want to find the sector area, let's call it A, sector area, like the area of this part. Do you remember what the formula is for the area of a circle?
Pi r
Pi,
squared.
pi r squared, exactly. But I don't want the whole circle, do I? I only want this portion of it. So how do you suggest what should I multiply this with?
Which section?
I want this section only, right? Just like before. So what fraction should I multiply this with so that I only get the area of this sector and not the whole thing?
Theta over 360.
Exactly. So this fraction allows me to say, hey, cut a slice out of that circle and tell me only the area of that. Okay. But as you can see, dividing by 360 means that theta needs to be in degrees, right? It wouldn't make sense to say pi
Yeah.
radians out of 360 degrees. That doesn't make sense, right? Your examiner is probably going to have an aneurysm if you say something like that. So these formulas are for like degrees, right? So the cool thing is that in radians, this exact same thing, the formulas become so much easier. If your angle is in radians, or if you convert your angle to radians, really, because you can convert them, then the formulas become much easier. So the arc length would simply be r times theta. That's it. And I can show you a very simple reasoning for why. Um, okay, think about it like this. The formula for arc length is this, right?
Yeah.
According to in degrees. However, if I convert everything over here in radians, what is 360 degrees in radians? Try to remember.
2 pi.
Exactly. So what does this formula become? The two pi's cancel out, just gives you r theta. So if theta is in radians, the arc length formula is simply the radius times the angle, and that's it. No fractions, no nothing. So the formula becomes super easy if theta is in radians. Gotta be careful. Okay.
Okay.
So
Okay.
you don't need to remember this kind of derivation. unimportant. The main thing to remember is that this is the formula if your angle is in radians. I keep saying if your angle is in radians, but you got to remember you can convert your angle to radians if it's not. So it's not really an if thing anymore. It's more like a do you want your angle to be in radians thing, right? Because you're free to convert them.
Yeah.
So, and the sector area similarly has a simpler formula. It's going to be 1 over 2 r squared theta. This is the formula for the area of a sector if your angle is in radians. Okay. And that is why
Okay.
radians are so cool. I mean, one of the many reasons why radians are so useful because they simplify the math so much. The formulas become simpler, life becomes easier in general. Now, let's do some problems, but before the problems, I just want to remind you of something that there's a formula to
Hmm.
find the area of a triangle. So if you have a triangle, any triangle, you can find its area. If you know any two sides and the angle between them, you can find the area using this formula. The angle can be in radians or degrees, doesn't matter. Okay. So the area of a triangle can be
Okay.
found with this if you know two sides and the angle between them, specifically this situation. Okay.
Wait, so you can use that formula no matter what, like if the angle is in radians or
Yeah.
degrees.
Yeah. But just make sure that
Okay.
in your calculator you set it to like the correct setting, because your calculator needs to know what you're giving it. So there's a on every
Oh, okay.
calculator there's a way to like set it to radians or degrees input. Depending on your calculator, you can like find out how to do that. For some models I know, but not for all of them. So let's try a question now. Let's try a simple one first. So can you take a look at this guy? I want you to find the sector length, which is here, and the area of the sector. What do you think? Is this angle in radians or degrees?
Radians.
Yeah. First of all, it has a pi, which is normally a telltale sign that it's in radians. But if it doesn't have pi, if the angle is like 2.1, and they don't say what the unit is, it's probably radians because it's so tiny. It's when the number is tiny, it's
Yeah.
always in radians because tiny numbers are actually big angles in radians. Only 3.14 is half a circle. Remember that. Like, radians are just
Okay.
very scaled down. You know, just because I'm saying, for example, 0.1 kilometer, even though the number is tiny, this is still a pretty large length, right? So
Yeah.
the same way, only 3 radians is half a whole circle. So it's a pretty big deal. So whenever you see small angles, they're probably radians. Anyways, so can you try to find the arc length? By the way, I want the answer in terms of pi, okay? So I don't want you to
Okay.
convert to decimals.
Okay. Should I like write on the whiteboard or just write it in my
Can you
notebook
write
and
on the
then
whiteboard? Do you have like a pen tablet?
I think so.
Really? No, like do you have a pen? Is that the Apple
Yeah.
pen?
Yeah.
Okay, go for it then. I thought, because some students are like,
Is
can
it
I write on
showing?
the screen? Yeah, it is, it is. And then the poor guy starts writing with a mouse, and I'm like, bro, it's okay. You don't have to struggle. Do it on your notebook.
That's so painful.
Yeah,
Okay, wait, I'm
exactly.
gonna write it like on the notebook and then like I'll put it back. Like,
Sure, sure.
wait, so is theta 3 pi over 4?
Yes. Yeah,
Is
that's
that right?
that's pretty much it. Yeah, but you gotta simplify it.
All right. Wait, I don't know. I didn't bring my calculator somewhere in my room. Wait,
Okay. No, don't need you don't need a calculator for this. Come on. What is 12 over 4?
3,
And what is 3 times 3? 9.
9,
Exactly. That's it.
9.
9. That's like a chic German.
Well, that was the most advanced piece of math I've ever done.
That's I don't know how to feel about that, bro. Okay, try to try to find the area now.
I'm joking. I'm joking. I'm joking. I'm joking.
Okay, I hope so. Definitely starting on the back foot otherwise.
Okay, wait, let me do this now.
Nice. 4 times 20 is 80. You gotta go 8
Where'd
back
20
for.
come from?
Think about it. 4 times 20 is 80, right? So you want to go
Right?
8 back from 80 to get to 72. How many fours is 8s? 2. So 4 times 18 is 72. 4 times 20 is 80, which means that you got 76 and then 72. So 4 times 18 is 72. See what I mean?
Yeah.
That's what I was kind of, a little trick you can do in your head. Anyways, yeah, 4 times 18 is 72. So 18 times 3 is uh 54 pi. There you go. That's the area. So simple enough, right?
Yeah.
Okay. So
Also,
let's.
I'm just like a little nervous right now. I don't know why. So I'm
Oh, it's okay.
like,
It's all right.
like,
It's all right.
like I don't like. Usually, like I could do this very quickly, but I don't know. Like
Mm-hmm.
I'm just,
No, it's okay. It's
you know,
okay.
when you do something in front of someone and then you're just
Yeah,
like, you just get like a
exactly.
little more anxious. Yeah,
Honestly,
that's just
it's not
happening.
because like I always tell my students, like a lot of people say this, okay, that when they're in the class, when they're solving a question, they always get something easy wrong sometimes. But it's good because like having
Yeah.
me around, like it's some like I'm simulating exam pressure. So if you can do it with with me watching, then you can probably do it in exam too. So
Yeah,
that's
it's like conditioning.
yeah, exactly. So I'm putting sandbags on you. So here's the next question. You want to find the shaded area? Let's do this as the final question for the
Okay.
day.
So would you find the area of the entire sector and then find the area of the triangle and subtract them?
Nice. Good job. Exactly. So you see, by the way, this is a
Okay,
common
let me do
misconception
that.
also. Just want to clear it out. So you see how this time the radians don't have a pi in them?
Yeah.
Some students like they start believing that the pi
Mm-hmm.
is what makes a radian. So that's not true. The
Yeah.
pi is just there for like I don't know. It just shows up occasionally in radians because there's just such a cool conversion. But it's just a coincidence. I mean, I wouldn't say it's a coincidence, but you can consider it a coincidence. Radians don't necessarily have to have a pi in them.
Yeah, so just like treat it as normal.
Yeah, like a regular radian.
Okay.
So how would you find the area of the okay, never mind. Sorry.
Oh, wait.
Exactly. But make sure you convert your calculator to radians because otherwise it's gonna give you an odd answer for this. Oh, whoa,
Okay.
go on.
Could I solve this manually?
I mean, if you're absolute genius, yeah, but I wouldn't be able to. Sine of 1.5, I don't think anyone knows that off the top of their head. But yeah, you can, just
Okay,
use a
so
calculator and, just do 50 times that.
okay, so this becomes 50. So it would be like 50
Sine
sine
1.5, yeah.
1.5,
Mm-hmm.
and then
But you're gonna need
subtract
a calculator
75
for
from
this. Yeah,
this
exactly.
to get the answer.
And that's the answer, exactly. So as you can see, not too tough, right? And of course, in the actual exam, you're expecting much more difficult questions. And
Yeah.
honestly, um, the next part of this chapter, where we talk about solving algebraic trigonometric equations, is where things really get interesting. Um, let's talk about that in the next class. So, I mean, if there is a next class, of course, I hope there is, but we'll go over
No,
that
there
in the
will
next
be.
time. Okay, there will or there won't?
There will. You're a
Oh,
good
okay, there
tutor.
will.
I like
Okay,
it.
perfect. Okay, thank you. I'm gonna stop the recording now. Because you've glazed me already, so.